record on this computer. All right, it's recording. Great. All right, so yeah, so for those of you who didn't get an Arduino in time or couldn't do the didn't do the asynchronous lesson, just build the TouchDesigner patch anyway. We can plug in some sliders for the time being to make it operate, to simulate the inputs that you would be getting from the Arduino. Yeah, and then do the asynchronous lesson and contact me if you have issues with that or need help. Okay. So yeah, let me show you. This is what you should have had. This is what you should have had after the asynchronous lesson. It's 3 different sensors and an LED. We have the LDR, light dependent resistor or photo sensor here. We have a potentiometer, which is like a fancy way of saying knob. And we have a button, right? And then also in TouchDesigner, share. Let's see. I think I have. This is kind of what we're going to end up with today. I didn't actually finish it. I'm going to have to work off of my notes and pray I get it all right. But we're going to have this Blobby Sphere, and the values from those different interfaces are going to change what color the sphere is and how blobby it is and how fast it's moving and stuff. So this is not the right file. Let me open the right file. Close this one. Yeah, my TouchDesigner sure hangs at 99% for a long time these days. Well, I think it's when I'm screen recording and streaming at the same time. There we go. Something happened. 100%. Why would you say 100% and not just start? There we go.
Just
okay,
to
great.
warn you, every time I've been opening TouchDesigner, my computer has just been overwhelmed and it just quits when I open a program like that. So I don't know what is causing that problem, but if in the case when I open TouchDesigner, you guys lose me in the meeting, just know that that is why, and I will do my best to boot up the computer as fast as possible after that.
No problem, no problem. Just try to stay with us as best to your ability. Okay.
Yeah. Also going to take notes just so in the case that I can't get everything done, you know, I can kind of refer back to that.
Great. Yeah, we'll have, and I generally post this screen recording on the class website by the end of today. And then I usually have the asynchronous lesson for next week done by either Friday or Saturday. Last week, it took me to the end of the day on Saturday because I had to end up recording it like 3 times. I was trying to do something fancy with OBS Studio so that I could have like little windows and like fade between one and the other, and it just it didn't tell me it wasn't working, and I thought it was, and then I go back and the final file is like every time I hit spacebar it had stopped recording, and the next time I hit spacebar it would start recording, so I ended up with a whole bunch of like little file fragments. And then when it was working, it was only like capturing at like 1 frame every 2 seconds or like maybe 5 frames a second at best. So I just had to go back and do it over again. But okay, so this is what you should have ended up with, which is we have the input coming from the Arduino into a serial object, and the Arduino is communicating at 11.5.200. You have to select the correct port here from port to be whatever your Arduino is attached to. That's usually USB modem. Sometimes it's, if you're on Windows, it's going to be like COM1 or COM3 or something like that. And then the message that we composed in Arduino is 3 values separated by a space with a new line character. And the normal way you would do a message like that is you use print, and then you do the first value, print the second value, and then print ln for the third value, because then it will put a new line in between the messages so that it doesn't just keep scrolling right on all your messages. But TouchDesigner really doesn't like that method because it puts 2 different characters. It puts a new line value and a carriage return, which really TouchDesigner doesn't appreciate. It like glitches out the serial, and you have to end up putting a bunch of different objects to filter that out. So in the asynchronous lesson, I show you how you can instead just manually print a new line character instead of using the print ln message. And then it creates this perfect stream of data that TouchDesigner really likes. So then we have then we are able, by using the select, we can just select the top line from this, start row index 1, end row index 1. So that chooses out of this stream, it chooses the most recent values. And then you notice here that those are in a 0 column and a 0 row, but only 1 column. So we split that out. We put this in here to split. We change it to table, and we split the cells with a space character here, and that creates 3 different columns so that we can easily then send that to a DAT2 to get 3 different channels. And clicking the button here creates you can see that value goes from 0 to 1. This middle channel is the potentiometer, and the top channel is the LDR, the light sensor. My HD camera here feed, if you're looking at it, tends to get really bad video delay. So whatever I'm doing is pretty far behind. So you'll see the channel change on the DAT2, and then like a second later, you'll actually see me press it. Which was really fun when I was recording the video. Okay, so before we get started, are there any questions or problems that you had with the asynchronous lesson that we want to talk about?
Jason, I had a problem, but I sent it to you, the screenshot of my screen. Yeah, it's a bit complicated to describe what's happened, but maybe you can take a look later, and yeah.
Let me just take a look right now. I'm not screen sharing anymore, right? Yeah, okay. Let me just take a quick look at what you sent me, and maybe it's something simple. Okay, here we go. Okay. So you have a syntax error in your programming, it's saying?
Yeah, something like that.
Okay, so it's saying, oh, there's an error occurred while uploading the sketch. Yeah, that can happen. Can't open device. Access is denied. So you're obviously on a PC.
Yeah.
Because I see COM, and it says COM3. So did you try putting it in a different? Try putting it on a different USB port on your computer. Sometimes some of your USB ports have problems, and sometimes other ones don't.
I can try it.
Yeah, try that. And if you've got all the code, and it looks like actually you don't have any syntax errors because it would have told you that prior to trying to upload it. The other thing it could be is if it doesn't detect the Arduino correctly. And on your board, on the type of board where it says Arduino Uno, what are your options there? Does it say, is there a different, because mine usually says like Arduino Genuino Uno.
No, I have only Arduino Uno.
And that's the only thing that's available there?
Yeah.
Okay. Let me just take a look. Yeah, did you try plugging it into it? Do you have it in front of you?
Yeah, I'm trying now.
Okay. Yeah, this is going to be kind of a short lesson anyway. I think this will only take us an hour. So if you have questions, we have time to, if you had problems, we have time to talk about them now before we begin. Because I would like everybody who can to be on the same page. Arduino, yeah, mine says Arduino Genuino Uno, but I mean, I don't know what the difference between Mac and PCs are. You could also try going under Tools, Get Board Info, which will tell you whether it's communicating properly. Also, if you had TouchDesigner trying to interface with it already, you would want to turn that off before you try to communicate with it by going to this. Here, let me go back to share screen real quick. Share. Okay, so if you're trying to make changes in your Arduino program and you've already tried to interface in TouchDesigner and you've selected the port here for your Arduino, right? And normally this is on active on. You won't be able to do anything on the Arduino IDE if that is still trying to communicate in TouchDesigner, because only one thing can communicate with your board at a time. So you'd have to turn this off and then go into your Arduino. And what I would suggest for you, Joanna, is to go to to try to get board info. And if it can read it like that, it probably has a good connection to it. If it can't pull that data up, then there could be something wrong with either like the driver that you're using to communicate with the Arduino or the port that you're using and have it plugged into.
With the board info, everything is okay.
Mm-hmm.
Yeah, I will try what you show now, then to do like off on this thing. Yeah, just give me a second.
So while we're waiting for her, I'll just talk about this code really quick for some of you maybe who didn't do the asynchronous lesson. I can just go over it really quickly. So basically, the way Arduino works, it's kind of similar to Python, but there's some difference. It's not white space dependent, so you have to use semicolons at the end of your lines to tell it where the lines ends. So here at the top, this is where we define some constants that are just defining what pins things are attached to or are going to be read from. So we have an LED that's attached to pin 13. We're going to be reading LDR values and potentiometer values from A0 and A1. And we have a button attached to digital pin 2. Then we define some variables like which will change, which is basically little variables that we can stick those red values into. And we have LDR value, which we're starting with 0, a pot value, which we're starting to 0, and button state, which we're starting as 1. And then we do our setup. We say pin mode, LED pin. We set up our pins to work the way they're supposed to. So LED pin needs to be an output. The button pin needs to be an input with the pull-up resistor turned on. And I talk about what a pull-up resistor is in the asynchronous lesson, but essentially it's a way of providing like a high impedance or a high resisting escape route for the electricity to go when you cut off the other route, because what you don't want to have is just to completely cut off the power from the ground. You don't want the power ever going straight through the ground to the ground without any resistance, but if you send it through a 10K resistor, then that won't start a short scenario, and it will provide a method, a place for the power to go so that you don't have an undefined state. Because if you try to read from a pin that's completely cut off, then it's going to give you a fluctuating value that just jumps all over the place instead of giving you a low value, like a ground value. Then we start our serial communication. Then we do our analog and digital reads. We read the LDR value, we read the potentiometer value, and we read the button state. And then we print out the LDR, the pot, and the button state values with the serial. And then here's that new line character that I was talking about. Instead of doing a print ln, we just say print and then this single quote, new \n single quote. And then we do a small delay for stability. So we keep the code in Arduino pretty basic, and we do most of our complicated code and in TouchDesigner. So how's it going, Joanna?
It's not really working, but yeah, I will try one more time, maybe
It's
with
still not working?
drivers. Yeah, the same problem. Yeah, but
Does
it's okay.
your
I will.
Arduino light up when you plug it in?
Yeah, yeah. Actually, you know, like everything is working until I'm trying to connect it to touch.
Uh-huh.
Yeah, if it's not connected to the touch.
You can't put the program on it, though.
Sorry, say again.
But you can't put a program on it.
I can.
Oh, you can?
Yeah.
So then what isn't working?
I just don't have the same what you have. Okay, I can do it maybe. Okay, I can try to share the
Share your screen? Hold on,
yeah.
I have to set that up. I think I forgot to change that. Hold on, let me stop sharing my screen, and then there's just one thing I got to click on. Multiple participants. All right, you can share your screen now.
Mm-hmm. So I don't know. I just did everything as you said, but I have this strange effect.
Oh, okay, good. So you are getting data. What? It's just all right. So let me see. Where? Go scroll over to the. Wait, maybe I just have my video in the way. Okay. Right. Okay. So yeah, you probably formatted. Show me your Arduino code.
No.
It's probably just that you have a print ln. Yeah. See that first one where you say print ln LDR value? You got to take that off. The ln. Take that off of ln. No. Right. Serial.println. It should just say serial.print.
Okay.
There, that should work when you upload it to your board. But you can't upload it. You probably can't upload it until you stop its communication in TouchDesigner. So you click on that and you turn the active to off.
Okay.
And now you can upload it on your thing, and that should work. Cool. There you go. Got it.
Okay. It was
awesome.
easy.
All right.
Thank you.
Yeah, no problem.
Okay.
All right, any other questions on this? I'm going to share my screen. All right, so I'm going to assume that everybody else who did the lesson got this far and it's working. All right, cool. So let's see. Coming out of this DAT2, so what we're going to do now is we're going to split this data up into 3 different channels, 3 different individual channels, because we're going to do a little bit of data massaging differently on each channel. Yeah, the first thing we want to do is, I don't know if it's going to have, wait, I have to start my active up again. There we go. Okay, so you'll notice if you look closely on my serial 1, my data coming in is fairly stable, but then all of a sudden you'll see like little flashes of values that are further to the right. And that causes a glitch in your data. And it's basically because the Arduino is not perfect at its serial communication all the time. So it will sometimes, and because the nature of serial communication is that it's not packetized, meaning it doesn't send you individual chunks of data. It sends you a stream, and that stream is broken into chunks based on timing. And so if the timing gets off, then the message may be shorter than expected or longer than expected, or just gets garbled, right? So sometimes it'll get garbled and data will drop out. Sometimes it'll be longer than expected, and sometimes it'll be shorter than expected. There's not a super good way to deal with that in TouchDesigner, aside from changing the way your Arduino works, or Arduino code works. You can, probably the best way to deal with it is, instead of sending a stream of data like we're doing here, a nonstop stream, we do a call and response system where the Arduino just stores its most current value and only sends it to TouchDesigner when TouchDesigner sends a ping to the Arduino asking for that data. And it can do that like every frame. But that was a really complex code that I just didn't want to get into because this isn't an Arduino programming class, and I can just live with the glitches. But we can mitigate those glitches somewhat by doing some filtering. And that will cause any changes happening from those glitches will be affected a little bit slowly over time. And if they're just transient and it goes back to the value that you expect right away, that change won't be heavily felt by your objects that are attached to it. And there's an object called filter that can do that. So you put a filter chop in here. So let me just show you guys what we have. We have a serial, we have a select one, or select, which is, and on the select, we're saying select rows by index, and we're starting on row 1, we're ending on row 1. Select columns all, output, input data. That's what we should have there. Then we have a convert, which we're on the how, we're saying to table, and we are leaving that off, and we're split lines at, and it's just a space here. You don't see it, but there's a space here. And then we use a DAT2, and then now we've done this filter. Okay, and I'm just going to leave this filter the way it is. I'm not going to change the parameters in it, but let me show you one thing. So what filter will do is it will add latency to the data as well as smooth it out. So like take a look at this button channel down here, which is a 1. The way we did this button is that it sends a 1 when you're not pushing it and a 0 when you are pushing it. And that's the way we read it by doing that input pull-up resistor. So, but watch it now. When I click it, it slides down to 0. And when I push it again, when I let it go, it slides back up to 1. So that's what it does. It adds latency to the data as well as smoothing it out. Okay? And that's fine for what we're going to be doing in this patch. So the next thing we're going to do is we want to select out these channels. So we're going to add a select chop, and we're going to tell it what channels we want to select. So channel names, you can actually, instead of typing the name, you can hit the arrow over here and say what channel you want. So I'm going to say Chan 1 here, and then I'm going to copy this and paste it to get this, to get another one. And on this one, I'm going to say I want Chan 2. But for some reason, when I do that, it tries to add it to Chan 1. So I'm just going to delete out Chan 1 so that I just see Chan 2. So I got Chan 1 here, Chan 2 here. And I want one more of these for the third channel. But the third channel, the button is really stable. Like, I haven't seen it glitch. And I don't want it to slide between 0 and 1. The other ones are fine to slide around. This one I want to split out before the filter. So I'm going to disconnect this and instead connect it directly from here. Oh, and this shouldn't be Chan 1, this should be Chan 3. Sorry, it shouldn't be Chan 2, it should be Chan 3. Right, so now that just pops from 0 to 1 and back to 0 again. Okay? Now we just need to do some ranging. So what I want to do essentially is I want to take the value that this LDR is seeing, and I want it to be at one value based on its like steady state with which will be different for all of you based on how much ambient light is in your room right now. Plus they tend to drift a little bit based on how hot they are. But regardless, I want one value. I'm going to do some ranging with a math object. Let's go ahead and add a math object here. And we're going to do a range. And we want this from range 0 to 1. We're going to change that to from whatever the value is when I'm putting my finger over it, something around that value, which you'll find it's hard to get like one consistent reading. So mine's tending to be 360. So I'm going to say from range 360, and then to range, I'm going to have what my current, what it kind of sits at when I'm not putting my finger on it, which is basically what the ambient light is. And mine, it's like 641. I'm going to say 650. Whoops, not 1650, 650. And then I'm going to map that range to a value between like 0 and 2. Okay? And so now you can see I get a value that goes down to 0 and when I put my finger over it, and hops up to about 2 when I don't have my finger on it. But sometimes you'll get values that are slightly lower than what you put on your range, and you can see it just kind of pop to negative numbers sometimes. And I don't want that because that will kind of throw off what I'm trying to do with this blobby sphere. So I want to actually just have it clamp those values at 0 so there's a maximum value of 0. So there's an object called, what was it called? I don't have it in my notes. Let me see, what is it called? Limit. Limit. And I can say type clamp. And then it asks you what you want your minimum and maximum values to be. I'm going to say minimum of 0, and my maximum is going to be, I don't know, let's just put it at a high value because I want to be able to like make it go over 2 if I like stick a flashlight on it. So I'm going to say like a maximum of 10. It should never get there anyway. Okay, so now if I put my finger on it, this should go down to 0. Actually, I want it to go completely to 0, so I'm going to adjust my range here to make it do that. So I'm going to say this from range, instead of 360, maybe I make that like 400. And then when I put my finger on it, it should go down to 0 and just stop. Right? Okay. And let's just work on this channel first before I go back to the other channels. So the next thing we're going to do is we're going to create a blobby sphere, which you may remember from the first couple weeks of this class. We're going to do that with a SOP, a sphere SOP. Sphere. Then we're going to put that through some noise. Which kind of creates that blobby sphere. But there's a better way to do this where this looks cool, but it looks even better when you recalculate the normals. Because right now this like hotspot is always in the same place, even when the contours of the sphere should be making that hotspot move. So if you recalculate the normals by doing a what's it called? It's a attribute create. Recompute normals. It gives the sphere so much more contour, right? It just looks way more 3D. So that's that. And so what we're going to want to do is we're going to affect the amount of noise going into this based on this value coming out of this. So before we do that, let's send this to a null chop coming out of this limit. I'm going to go to a null chop. And let's give this name a name, and we'll call this LFO value. Not LFO, LDR value. All right, and so now we're on our noise here. We have an amplitude, right? And you can see if you grab this amplitude and you drag it down to 0, it doesn't have any noise. And if you drag it up to 5, it gets ridiculous. So I can, instead of having a constant value here, I can use a relative chop reference here and just send it to from that LDR value. So I'm going to say op, open parentheses, single quote, LDR value, single quote, close parentheses, and then it's a chop, so you have to have the brackets and you have to tell it what channel to look at. And I could either, what's it called? I could say single quote, chan 1 there, or even easier, I could just specify it by index. It's the first channel, it's the only channel, so that's going to be channel 0. That's the easy way to do it. Then it doesn't matter what its name is. All right, so now you can see that sphere is now have an amplitude of 1.9, and when I put my finger over the LDR, it goes down to a sphere. Right, so now we have some we have some results coming from this from the input sensor here that's affecting our 3D object. And so you can adjust this. I think maybe sitting at 2 as its default state is maybe a little too wild. So I'm going to come up here on my math object, range it, and just change this back to 1 maybe. I think that looks better. And so now it's not as crazy when it's just sitting there, but it goes down to 0. And if I want to take my cell phone flashlight and put that on the sensor, then I can make it ping to higher values. Okay, so that's cool. Any questions on this so far? All right, so we're going to do some other things. The next thing I want to do is I want to take this value coming from the potentiometer and adjust the speed at which this blobby uh, the blobbiness of this blobby sphere is moving, right? So you see on the noise here, there is, let's see, is it under transform? Transform, the way the noise works is it's like moving through a noise field through a translation. I don't know if you guys, I wasn't here because I was on family leave, but in my videos on the first couple weeks, I think we talked about the noise top. And by default, the noise top is just static, right? But you can make it animate the way that this animates by doing the same sort of thing on transform. So if I go on translate here and I say, what is it? It's like, I can't remember what the parameter is called. It's here. Abs time.seconds, right? Which is a value that changes every second. So if on transform Z here, I would say abs time.seconds, then that animates that noise the same way that it's animated by default in this noise SOP, right? So how do you think we could, if anybody want to venture a guess how we could take this value coming from the potentiometer and change the speed at which we're translating through this noise? Does anybody want to venture a guess? I'm going to give you 4 seconds. All right, we're all awake. Okay, so first thing, let's massage this data into some useful values with a range. Sorry, with a math object doing its range function. And the input value, I believe this potentiometer, if I slide it all the way down, all the way up, it goes from like 1023, and then all the way down goes to 0. So the input range is from 0 to 1023. And then let's say that we want to change this from 0 to maybe like 3 times normal speed. So I can say the 2 ranges 0 to 3. And so now when I drag this all the way one direction, it can go up to 3. All the way down the other direction, it goes to 0. So a lot of times when people are comfortable enough to wager a guess as to how to do this, they would say you could take that value and multiply it by your seconds here, right? If I said times 0.25, this should go, whoops, what happened? There we go. If I multiply this by 0.25, you can see it's going a quarter as fast. If I multiply this by 0.1, it should be going a tenth as fast, right? So if I said, let's go ahead and actually on this value here, I don't think we need a limit on this one because it doesn't really go outside of those ranges. Let's just send it to a null chop and call this one, we're going to call this, what is it? It's a potentiometer. So we're going to call this pot value. Okay. So I could, on this noise here, I could say times op, open parenthesis, pot value, close, single quote, close parenthesis, open bracket, 0, close bracket. And then that would be affected by that value, right? But there's something a little bit funky about this. And you'll notice that, see this noise, and it'll happen here, and we could do it here too. So abs time.seconds on this noise SOP, It's even more clear on the noise SOP the problem with this. We could say times op, open parenthesis, single quote, what is it, pot value, single quote, close parentheses, channel 0. See how that, it's like glitching like crazy, and it kind of goes forward and backwards, right? Because this is actually, it does change the speed, but it's changing when you can see this translation is a number that's growing, right? And if you're changing what you're multiplying that number by, and then you're multiplying that number by 1, then that's fine. It just keeps counting up. If you're multiplying by 2, that's fine. It'll still counting up. But if you multiply it by 0.5, that number is going to go down, and which will actually reverse the direction at which you're translating through that noise. And so you go back through values that you've gone through before. And so it moves back that noise in time. So instead of translating through the noise in this kind of new naive way, we need to create a system that will always be positive values. We could probably do that with limit, the way we did here, and make it so that it's always 1 and maybe goes between, or we could do it maybe with our range and go range it from, instead of 0 to 3, it goes from like 1 to 3. That would probably work. Let's try that real quick. That's not how I did it in the notes, but I think that might actually work. It's still glitchy. It's still glitchy, and it just doesn't give you and it's still going down, because even if it goes from 2 to 2, even if it goes, like it was multiplying it by 2, and then it all of a sudden hops down to 1, those values are going to slide backwards from where they were, which will go back in time. So that just doesn't work. So a year ago, when I first encountered this issue, I beat myself around the head for a long time to try to figure out how to fix this problem. And basically, there's not a good way to do it, but there's an object, with math, I mean, but there's an object that does it really well. And it's called speed. Because basically, that's what we're doing. We're trying to adjust the speed of this thing. And then there's a speed chop in here. And if you just hover over speed chop, it says convert speed, units per second, to distance, units, over a time range. So that's what we're doing, basically. We're having a value that we want to represent how fast it's going to go, a unit per second. And we want that to change an incrementing value at a different rates, right? More generally, if you give it a rate, the chop input, and it outputs a cumulative value, like what we're using to drive that translation. So that's really what we want. So I'm going to grab a speed here, and I'm going to put it in between our math and our null. And now we always have a cumulative value on this pot value, and our attribute, and actually on this math, I'm going to change the from rate, the to range back to 0 to 3. Right? And so now it shouldn't glitch as much. It's going really fast right now, but if I slow it down, if I slow it down, what's going on? Oh, that's right. Okay, so then instead of doing this multiplication stuff, we now can get rid of the abs time.seconds and just reference the pot value. Same here. And now we get something that makes sense. And if I scroll this down, I can make it slow down to nothing. And if I scroll it up, if I turn it up, it'll go faster and faster. Okay? Any questions on that? That's the first two channels. The last channel we're going to work on is the button. All right, I'm going to get rid of this noise top. We don't need it. Actually, before we go any further, let's go ahead and set this up for rendering. Right now, it's not really rendering anything. So to do that, we need, what do we need? We need a geometry component, we need lights, we need cameras, and we need a render, right? So we need a light comp. We need a camera. We need a geometry. And I don't know how I can't remember how we've been doing geometry in the past, but you see it gives you this torus inside your geometry, and if you go inside the geometry component, they've stuck a torus top in here for you. You could put all of your SOPs, rather not top SOPs, you could stick all of your SOPs inside the geo, but that would just be pretty annoying because then we'd have to change all of our references, of all of our relative references. And there's another way to get the SOP inside this geometry component. First of all, we don't need the torus. I'm going to get rid of that. So we could just send it in there with an in. So I could have a in SOP like this. And then I can actually just patch it right in there. And if you go inside the geometry component, you're like, oh, there it is. You'd have to then turn on your rendering for this and maybe your display, and then you'd actually see it. And that's cool. That works. There's an even easier way I should show you. If I delete this and I just right-click on the output of this attribute create, which is the last thing on our chain, and then I go to geometry component, it'll do all of this for me. Boom. Just does it right off the bat. It actually adds an output as well, in case you want to pass this SOP to something else. Okay, now we need a render top. Boom. All right, so now we're rendering. You can see it draws these lines between it. And then to actually send it to performance mode, we'll need an out top. Cool, but instead of doing performance mode, I'm just gonna push this display button, which will put it in the background. So we can patch on top of it, but still see its output. Ooh, okay. Next, we are dealing with this button. First thing is, this button's input is kind of backwards, I think, from what we want. Right now it's 0, and it's a 1 when I'm not pushing it, and it's a 0 when I push it. So there's a couple ways I could deal with that. I could change the code in Arduino, which is what I did last year, I could say that the value is the digital read, but you put an exclamation point before it, which is the opposite of what it digitally reads. But I'm just going to deal with it in TouchDesigner. I could also just do a math object that does a range. So math, and say range from 0 to 1 to 1 to 0, which would flip it around as well. You can also just do it with any kind of relative reference. You can put an exclamation point before that value, which will give you the opposite of that value. I guess I'll just leave it as math for now. All right, so I have this button input, and what I want to do with it, I'm going to make this blobby sphere change colors. random colors every time I click the button. So the first thing I think I want to do, let's set up our SOP for colors and create like a constant to hold those colors. So right here, I'm going to create a constant chop. And instead of one channel, I want 3 channels. So I can add channels to this constant chop by putting them here. But instead of doing chan 1, 2, and 3, like I'm doing R, G, and B. So I'm just going to name them R, G, and B. Okay, so those will represent the colors. Then to actually create that color and apply it to a SOP, does anybody remember what we use to apply a color map to a surface operator? Anyone? Anyone? What? What'd you say, Kathleen?
We're applying a it's a Fong, right?
Yeah, Fong, exactly.
Okay, great, cool.
Thank you. I'm glad somebody's participating. I just feel so alone out here. Okay, yes, a Fong, right? And let's see, what do I do with this Fong? I can then, you can see that here under Fong, there's a thing called RGB, and it's the diffuse color here. I can set this color, by default it's like gray, but I could set it, say I wanted it to be green. I could click green here, and you can see that if I can close this, my video stuff's in the way. Get out of the way. If I close this, you can see that there's 3 different values here. So for this lime green, it's 0.3 in the red channel, it's 1 in the green channel, and 0 in the blue channel. Right? So I can attach these these constant values to those values. To actually apply it to this sphere, I'm going to need to have a material SOP that references this Fong. Let's name this Fong actually. Let's call this color. Okay, and then coming out here, I want to insert an operator, and it's going to be a material SOP. And the material that it's going to reference is called color. We just named it color. Right, and so now it's green. And if I change this value to something else like blue, it turns blue, right? So now we need to create those references to the constant, because that's what we're going to actually use to hold these color values. So here under the diffuse, if I hit the plus button here, then you see you get these 3 parameters, diff R, diff G, diff B, and they're set to constants right now. If I change those to relative references, and I could go ahead and type in op constant 1, channel R, channel B, G, channel B. There's another way I easily do this is I can make it viewer active and just drag this right on there and say chop reference. And then it makes that reference for me. Chop reference. Chop reference. There we go. And now it's turned.
I'm sorry, Jackson. I just missed this. How you get color to this soft material?
Yeah, you gotta have to have a material coming out of your attribute create, going to a material SOP, and then from there patching into the Geo1's input.
I mean funk material to the soft material.
Yeah, your material, you need to specify the name of the Fong, which I named color.
Okay, thanks.
Yeah. So right now it's black. Why is it black? Anyone? No one wants to venture a guess? Probably because it has 0 red, 0 green, and 0 blue. If I start dragging this red up, you can see it turns red. If I start dragging the green up, it should start turning amber. And then it'll start turning green. If I start dragging the blue up, it'll start turning white, and then it will turn teal, or kind of a whatever. So I can move these sliders around to change its color. Right? So now we want to create a system that randomly assigns these color values to this constant. We have a 0 and 1 coming out of this math. Let's actually send this math to a just like we did up here. We're gonna send it to a null. And let's go ahead. We named all the other ones LDR value, pop value. Let's call this button value. Right? So then, anybody want to guess on how we can get random numbers? We did this before in our slot machine. What do we use when we have a 0 to 1 button value, and we are using that to execute code that randomizes things? It's like the main object we use to run code on a value going from 0 to 1. Nobody's going to answer? Some brave soul. I'll give you a hint. It's a DAT.
It's a chop execute.
Thank you, Kathleen. Right. Chop execute. Come on, guys. I'm looking for a little bit of participation, especially because, like, if you make, I know it's a little scary, especially when you guys aren't sure, but when you make these kind of leaps, and then it's going to cement this knowledge in your brain a lot better than just watching me do it, right? Because then you actually have to engage your brain and make hypotheses about way things work. I mean, coding is really a scientific process, because especially when you're doing something that from scratch that somebody hasn't done before, you have to make a hypothesis about how you think you can make this work, and then you scientifically test it to see if it works. And if it doesn't, you make an adjustment and you test it again. That's the scientific method, right? So I'm looking for these hypotheses from you guys. All right. So we have a value that's going from 0 to 1. That's an off to on. So that's the code we're going to use. So make sure you turn that on in your parameters. We're going to turn off value change. We won't be using that. And then let's add some code in here. All right. So first of all, I don't know if we've ever said this before. If you're only using one function of the chop exec, you don't necessarily have to have all these codes. All this other code doesn't do anything, because all it's doing is, if it happens to run that, it's immediately returning, meaning it's not going to do anything. Let's just delete it. We don't need it. Okay? If we wanted to, we can even clip out all this. This is all just comments. They don't do anything either. I'm going to leave them for now. So all we're going to do is the off to on. And this is where we need to add our randomizing code, right? And we need to set our value 0, value 1, and value 2 of that constant that we called, did we name it? I can't remember. No, we just called it constant 1. Let's name it. Let's name it color. Color value. Oh, and now that broke because it's looking for constant 1. You know what? Let's just re-export these. Chop reference. Chop reference. Chop reference. There we go. All right, color value is what it's called now. We wouldn't want to name it color because that's what we named the Fong, and you don't want operators that are both called the same thing. I don't think it'll let you. If I tried to name it color, I think it would rename it color 1. Okay, so we're going to say op color value. Oh, don't forget your single quotes. And channel, let's go ahead and this time specify the name, channel R, single quotes around the R, brackets around that. That will reference that channel, equals, and now we're going to create a random number. You probably won't remember, but there is a function for making random that we used in the slot machine. Does anybody happen to remember that? What? No? Okay. TDU, TouchDesigner Utilities dot rand, and then you have to give it a seed. Remember that? Just say yes, somebody.
Yeah.
All right,
Yes.
thank you, Sai. We give it a seed, and we use. Anybody remember what we used to generate the seed so that it's a different seed each time?
It was like something times 3 plus 5.
Abs time, absolute time. Yeah. Dot, and then you have to tell it like frame or seconds or whatever. I'm just going to say frame. Abs time dot frame and close parenthesis. All right. And then this one you can do, just copy that line, paste it in. Now if I did this, and change this to G, anybody remember why this would not work correctly in slot machine? Sai, you had put your finger on it the last time you spoke up.
Because it would like, it would try to reference a value that didn't exist yet or something.
That's close. It's actually referencing the same value as the other one. It would work. It would give you the same value because this is the same seed as this is. And the way the random works is it doesn't give you a true random. It gives you a random value based on a seed. So if you send it 2 of the same seeds, it gives you 2 of the same random values. So then all your colors would always be the same random value, which would just be, it would basically be different shades of gray, right?
So if you wanted it to be a different value, would you change frame to seconds, or would you put a number in there?
You just add 1 to the value, because
Okay.
the frame plus 1 is going to be a different seed, which will be a completely different random number. So basically, just like if you were using pi for example to generate random values, and you're saying I'm going to use different place values of the digits of pi, so like 3.141526, like 3141526. Each of those place values is completely random to itself, or to the other place values. So even if you increment that random thing by 1, it's always going to be a completely different number. It's not going to just be the last number plus 1. It's going to be a completely different one. So all we have to do is just say abs time plus 1 on this one, and then what do you think I should do on the one after that? Plus what?
Plus 2.
Yeah, there we go. So that will give it 3 completely different random values. So now this should actually work when we send it on to off. Did we actually specify our button value? We did. Okay, so now if I hit the button, uh-oh, I did something wrong. What did I do wrong?
Is it G twice?
What?
You have
Oh, I
G-
did say G twice. You're right there. RGB. And it still did something wrong. Let's see. TDU constant chop object does not support item assignment. Oh, yes. Okay, so I did this wrong. Because you can't, when you reference channels, and if I look closer at my notes, I would have not done this. You can't, when you reference channels this way, it only reads the value. It can't set the value. If I want to set the value, I have to use the par. And the parameter is called like value 0, value 1, value 2. So I have to say color value dot par dot value 0. And on this one, I have to say dot par dot value 1. Something that's really annoying to me in TouchDesigner, because I wish you didn't have, you could just use the same thing to both read and set values, but this is the way it works. par.value2. This should work now. Yep, every time I hit the button, I get a different color. Sometimes I get the same color because there's not enough of a difference between it. All right, that's basically what we wanted to do, but there's one thing we can make this cooler by doing, and that's to make these values slide from in between each other. And we've already used an object that does that, the filter here, right? Because that makes it slide between its last value and its current value. So I can just like stick a filter in between this button value and the math, between the math and the button value. Ugh, stop it, move. There we go. So if I insert an operator here and stick a filter chop, wait, is that gonna work? No, that's not gonna work. Sorry, that's not where I do it. Because we don't want this 0 and 1 to slide because that's just what's executing this. We want it to slide from where it's coming out of this chop here, right? Before it goes into here. So I need to attach a filter to this. And let's name this filter, let's name it color slide. Okay, and then one last time, we got to re-export one more time on this. So now instead of exporting directly from color value, I'm going to export from color slide. Chop reference. Chop reference. Chop reference. And so now it should slide between values. Yeah, so I can put my finger over the LDR and that calms it down, like putting a sheet over your bird cage. I can change how fast it moves by adjusting the potentiometer. So nice slow movement like that. And I can change the color by hitting the button. Okay, that's basically all I was going to do today. So those of you who didn't have an Arduino, let's just take a couple minutes to show how you can simulate these inputs. Hopefully you were with me with the rest of the code, but all you'd have to do, say, is, let's see, we want like 2 sliders and a button, right? So let's try that. Move this video out of the way. We need a slider comp. And another slider. And what did we have for the range on this slider? The first one went between, it's on this math here. So my first one went from like 400 to 650, and my second one went from 0 to 1023. So coming out of this, I'm going to go to a math chop. And range from 0 to 1 to 400 to 650. So that should simulate that value. And then this one coming to a math chop goes from range 0 to 1 to 0 to 1023. and then a button. That one we shouldn't even have to do anything with. Other than, actually, our button was like the opposite, so I guess we do have to. So this is a momentary button, and then one math object here coming out of that maps the range from 0 to 1 to 1 to 0. These now have inputs that are similar to what the Arduino is spitting out, right? 400 to 650, 0 to 1023, and 1 to 0 back to 1 again. And I can just, let's see, let's merge these into a single stream with a merge so that I get 3 channels like this. Right? And then you can just plug that into your filter over here. And so now I'm not using my Arduino anymore, but I can, what happened? Something broke. This is mad, probably because of the name of our, probably the channel names of something broke. Why isn't that working? It's probably because they're called V1 and they were called Chan1 before. You know what? I think we can just fix that. Let's see here. On each of these maths, where do I change that? Its name. Merge, maybe under the merge. Oh, I don't know how to change that. All right, hold on. Why did that break? That shouldn't break. Oh, because it's looking for Chan1. That's where it broke. Okay, so here it's looking for Chan1. So I'm just going to say this is going to look for V1. And this one here is going to look for V2. And get rid of that. So it's just looking at V2. And then this one is going to look for, oh, that's still attached to that button. Hold on. So this one, because I attached it to the filter, I need to also patch it down to this last select for the button. And then say that instead of looking for Chan3, this is looking for V3 and get rid of this Chan3. And so now this thing should work the same way as with your Arduino, but you have soft buttons. So if I slide this down, you can see it's changing the amount. If I slide this, I can change the speed, and the button should give me different colors. Okay, any questions on that? You don't have to do that if you had the Arduino. All right, is that it? No questions. All right, I'm gonna stop screen sharing for a second.
No.
Yeah, question.
No, it's working.
Okay, great. Stop screen sharing. All right, so your homework, let me change my camera. All right, so homework for next week. I'm just gonna keep it simple. I think we should add add 2 more LEDs to your Arduino and 2 more buttons to your Arduino. So you should be able to, and I can point you guys in the right direction. There's lots, first of all, there are a lot of tutorials on how to wire buttons and wire LEDs to your Arduino device. But essentially, you just have to expand on what we've done, right? So let me go back to screen share real quick. No, not screen share. Yes, screen share. Yes, I want to screen share. Let me show you the Arduino code that we have. So, right. So you might want to have to, you would probably want to change button pin 1 and make a button pin 2 and a button pin 3. And these would probably be pins 2, 3, and 4, right? And LED pin 1 and pin 2, pin 3, pin 2, pin 3, and say you're going to use pins 13, pins 12, and pin 11. Or if that gets confusing, maybe you could make this pin 3 and this pin 2, this is pin 1. That way it's 11 is 1, 12 is 2, and 13 is 3. That's a little less confusing. And then, when you're reading it, you're going to be reading digital read button pin 1.
Jackson, your mic's kind of weird.
Yeah, I can't.
My mic's weird?
It's good now, but it was really weird a couple seconds ago.
I was wondering whether it was on your side or mine.
Oh, sorry. It must be streaming problem. Can you hear me now? All right.
Yeah,
so
now it's good.
I was just showing you how you can expand the code here to deal with these different things. You would have to here, every place where you've referenced LED pin, button pin, you would have to reference LED pin 1, pin 2, pin 3, button pin 1, pin 2, pin 3, right? So
Jackson, we lost you again.
yeah.
Can we try if you
Okay.
your camera for a second?
Yeah. Wait, what?
Maybe without the streaming of your camera, it's gonna work.
Okay, hold on. See if that's any better. So LED pin 1, pin 2. Can you hear me? Are you guys there?
Yes, we can hear you.
Yes, hear you.
Okay. So just going here and expanding the code to read these different things, right? And setting up the pin modes for each of them. And then creating the states for each of them. So let's see, you only need to do button states. You don't need to change these LDRs or pot values because we're only going to use one of those, but I could say button state 1 equals digital read button pin 1. Button state 2 equals digital read pin 2. Button state 3 equals digital read pin 3. So this is pin 2, this is pin 3. Okay, and then you're printing out button state 1 and then another space. Then button state 2. And then button state, and then another space, and then button state 3. Right, so that would be all you really need to do for the code. And then you'd have to actually then do your wiring, which I can, let's see here, let's stop my screen share. So that was pretty elementary, right? It's just expanding your code. And if you get really stuck on it, we can make an appointment and I can help you go over it. But basically, once you do that, then you'll just have to figure out how to add some buttons next to this one and another one here and wire those the same way that you wired these. And with the buttons, really, there's nothing complicated. You don't have to use extra resistors or anything the way you did with the LDR. It's just going to be going, one side of the button's going to be attached to where the power is coming in, or sorry, where the ground is coming in, and the other one is attached to the pin, right? Well, when you do the buttons with that style of input underscore pull up, it really is just two connections, one between ground and one between the pin that you're reading. So wire those the same way that we wired this one. And if you go back to the asynchronous lesson, there's some Tinkercad examples that lay this out in a much clearer way, where all the lines are nicely drawn, right? So it makes it more simple. So your homework is to add 2 more buttons and 2 more LEDs. The LED is pretty simple. All it is one thing coming from the power. One thing coming from the pin that's going to energize it. So this one's currently attached to pin 13, right? Then you'll want to add one to pin 12 and one to pin 11, and with that code that we just did. And then before it goes back to ground, it's best to pass it through a 220 ohm resistor. Otherwise, eventually you'll burn out your LEDs, okay? So I did that in the asynchronous lesson. You should be able to just do that with 2 more LEDs. This homework will prove that you understand how the breadboard works, and that you understand how the wiring on this works, which I think is important to be able to do it yourself. If you get really confused, just make an appointment with me and I can help you a little bit further. But that'll be your homework, to add that stuff. Next week, we'll look at the Arduino, or communication between TouchDesigner and the Arduino, sending it back to the Arduino. So we're going to make those see, in the asynchronous lesson, we started making this thing blink, and then when we actually added the potentiometer and the button, we just turned off the blink functionality, because it slows down the data input to do it the way we were doing it. So instead, we're going to redo this in TouchDesigner and redo our Arduino code so that we can send values from TouchDesigner to turn those 3 lights on, right? And we'll use the extra buttons to do some other stuff. I haven't figured out exactly what, but it'll be something interesting, okay? So that's your homework, is to add that stuff, okay? Questions about this?
I have one thing is, like, when I did everything with the asynchronous lesson, the only thing, like, it works, but my serial monitor, and then the DAT in TouchDesigner would show a different, like, it would show the same way as your data, but it would show a different value. Like, yours might be at 600 something, but mine would go all the way down to like 20 something for the first digit. Like, it works. I don't know if that matters in the.
Yeah, no, it doesn't matter. I mean, you're probably talking about the LDR, the light sensor, right?
Yeah.
Yeah. So there's a couple things that can totally change your values as opposed to my values. The first of all is just like the amount of ambient light that's in your space. So like if it's darker, you're going to get lower values. If it's brighter, you're going to get higher values. I have it pretty bright in here because I'm also trying to illuminate my breadboard and stuff for my camera. So I get some high values. Second thing is, even when you put your finger on it, the LDR is going to get light from underneath the sensor shining through the body of the sensor, is going to make it have higher values than 0. The only way to get really close to 0 is to completely cover it with like a cloth or something opaque to completely isolate it from light. The third thing is that the values tend to drift based on the heat of the sensor. So it's not a high quality device. So like if you are always expecting to get a certain value from a certain light range, you're gonna have a bad time, because it'll give you different values based on how hot the sensor is.
Okay, good. It's just wasn't really sure if I was supposed to like
Right.
next
So
lesson we need to base on the value of that.
So yeah, that's why I said when we did our ranging on that math object in TouchDesigner to just go ahead and see what values you're getting from the sensor and make your ranging based on that. And that's going to change each time, right?
Yeah. Okay.
Cool. Any other questions? All right, cool. I haven't responded to your guys's what's it called? Final project proposals. I'm going to try to do that today or tomorrow and send you emails back based on that. If you haven't given me your project proposal, make sure you do it right away. We really need to get on that. We only have a couple more weeks. Let me talk about the schedule really quick. So we did pick up an extra week, which is great. So before, like, classes used to be the last class here. Oh, let me go to screen sharing. I forgot. The last class used to be like week, oh, come on, computer. Here we go. Used to be week 13, which was 429. But because of the COVID response and stuff, they gave us an extra week, which is great. So we have an extra class on 5.6 that I'm currently just using as a user's choice. So we're going to use
The sound is insane again.
Ugh. It really doesn't like my screen sharing. Hold on, maybe if I stop my camera, stop video. Can you hear me now?
Yeah, the signal's still a bit shaky, but we can make out what you're saying.
Okay, sorry about that. We're almost done. So yeah, we picked up week 14, which is great. So we'll probably use that as mostly lab time, but also maybe a user's choice. So I'll poll you guys after week 13, after the 29th, to see about anything you might want to cover. Usually these are topics that have to do with your final project. So you want some like guidance on some function or how you could do something. We can talk about that on our meeting on the 6th. And then your final assignment is going to be due on the 13th. And I'd like us to, as much as possible, try to meet and present. You definitely need to like present your final to me and to everybody else, because I'd like us to see kind of what the final project, what we came up with, and for each person to be able to ask questions about how did you get that to work, you know, what were your major challenges, and explain how your code works so that we all can like see and learn from each other on that last day. So that will be on the 13th. We could do that on a different day if we all agreed on a different day. I just have it at the same time as class right now. Does anybody know of a reason why why 513 wouldn't work for them?
513, that's fine. I'll just be in China, so if everything goes well.
Okay. Well, you should be able to still, I think Zoom is available in China. When are you going to China?
Hopefully the 5th, but that's fine. I have the VPN and all that.
Oh, you have a VPN. Okay, great, cool. Yeah, so you anticipated my question was whether you can see YouTube or not. Okay, great, cool. Yeah, and please let me know, anybody, if they can't see the YouTube things. I can post it on Chinese video hosting. I don't want to unless I have to. So let me know if I need to. All right, cool, guys.
Maybe you'll get really high views on Chinese website, then you become very famous.
I highly doubt it, but maybe. All right. Okay, so let me stop screen sharing. Let me turn my camera back on. And yeah, so that's about it for today. Again, please you know, send me an email if you need help with anything, or you know, if you're having problems with the Arduino wiring or having problems with any other homework. I'm hoping to get all of your guys's, I think I said by next week I'd like to get all of the slot machine stuff in so that we can put that one to bed. But all the recordings are there. You should be able to walk through anything that you're behind on. I'm being really flexible with homework. I'm not really good. As long as you do the assignment from here on to the end of the semester, I'm not going to count it late, okay? So I just really want to see that you've done all of the assignments for the semester. I'm not going to ding you guys for being late. We all have weird schedules. We all have weird issues where we can't participate in real time. That's kind of why we're doing this asynchronous thing. Yeah, if you have any other like major problems, they're also being really lenient about doing incompletes in this class. So if you're going to be around next semester and this is just too much to handle, let me know and we can talk about an incomplete. That should be a fairly straightforward process as well. Yeah, other than that, take it easy. See you next week. Look for the asynchronous lesson for next week on I should have it posted either on Friday or Saturday. Okay?
Thank you, Jackson. Thank you so much. I'm in the process of sending you an email right now, so look for that.
All right, cool. Later.